All right. Hi, how are you? This is the inaugural edition of the newly resurfaced HR Examiner, A Deeper Conversation podcast. For those of you who don't know, I'm John Sumser, and I'm the host of this thing. And today we have Heather Bussing, who is a partner at HR Examiner and the most amazing employment lawyer on the scene, and just a general smart person to talk about some of these things. And so today we're going to do the exact opposite of what this will be most of the time. And Heather's going to interview me about AI. And from this point on, it'll be more conversations that I lead. But we're going to start this way. So, Heather.
Hi. I am delighted that I get to ask you questions for your first podcast. Thank you for inviting me.
Go.
Yeah, well, the idea for this session today came about on LinkedIn actually because I was asking John in public how AI worked, and it turned out that a lot of smart people we know also have questions about how AI works. And so I thought it would be a great thing to talk about that today and to sort of lay the foundation for some of the things that I know you'll be talking about probably with me and with many other guests. So where I wanted to start was with AI, and you've been writing about AI for 10 years now. And so why don't you start by giving us the how we got from big data to AI?
Well, so I'll take that and revise it just a little bit.
I would expect nothing else.
Yeah, well, so I have been writing about the topic for almost 20 years. Um,
Okay.
and one of the interesting stories that I want to tell you is in the early 90s, I made friends with an amazing woman who wrote the textbook on AI in the 70s. Uh, and and she was in the second generation of AI people. AI started AI started just after World War II, and there was a lot of computing capacity available. It had been used to build ballistic tables for the military and to do radar research for the military. And
And you were involved in that, right?
no, I was not alive just after World War II.
Well, sorry. Sorry.
although, although,
I
although,
didn't hear radar, and I went, oh, John did radar.
yeah, no, that's right. There's a John did radar story here somewhere. But I wasn't at the beginning. I was not.
Okay,
I do
fair.
not have paternity in this case. So after the war, there was a lot of compute capacity available, and the smart people at MIT started trying to figure out how to build a brain. And there were two people in that conversation. There was uh, Norman Wiener, and I'm going to forget the other guy's name. Claude Shannon. Claude Shannon developed information theory, and Norbert Wiener developed cybernetics. And early looks at AI were a combination of those two things. What ultimately happened is the cybernetics piece rolled off and really went underground, and the information architecture, the Claude Shannon view, came to dominate things. The Claude Shannon view is that communication is a series of observable behaviors that can be binary. So Claude Shannon is where binary code comes from.
Okay.
Uh, and the whole computing system that has evolved is built on that binary system. The Wiener view is that processes are what's important, not answers. And so symbolic logic and those sorts of things that get closer to what human beings actually do are in this long dead piece of cybernetics. And over here in information science and communication science, you have what we have today. And so you have these things that are really good at filling in little blocks on a checklist.
Right.
That's most of what you see in computing has been, up to the last couple of years, little empty spaces on a form that you filled in. And that work of putting data into forms is the foundation of a lot of the stuff that's going on today, but it's
Right.
been over time. So after that first wave, there's another guy named Marvin Minsky in that wave. Marvin Minsky is responsible for writing a book called Society of Mind. And Society of Mind is 300 pages of detailed architecture of all what we would call agents today, all of the agents necessary to build out an entire mind. And it's 75 years old. You know,
Okay.
it's a long time ago. After the initial enthusiasm, they started to run into walls because computing capacity has always been the limitation, right?
Right.
You either have a storage problem or a processing problem,
Right.
and throughout the history of computing, the storage problem gets solved and then processing overtakes it, and the storage problem has to get solved again. And so that's the underlying foundation. There was the first AI winter after that initial thrust, and then NASA, about 15 years later, NASA started looking at artificial intelligence again. There was a second flourishing, um, followed by an AI winter. And then in the 80s, there was a third flourishing, followed by a very long AI winter. And we're now perhaps on the edge of the fourth AI winter, or perhaps on the edge of there never being another AI winter. And we don't know because we don't
Right.
know.
Right.
Um, as processing and storage have expanded and expanded and expanded, lots of interesting things became possible. So, in the beginnings of the 2000s, post .com crash, there started to be a data explosion. One of the sayings that I really like is that data makes its own gravy. It's a reference to a Purina dog chow commercial from 40 years ago. So most people listening to this probably won't get data makes its own gravy. In the commercial, you added water to the dog food and it made gravy. So
Is this how we got the expression "we eat our own dog food"?
no, but it's a great
Oh,
that would make a great story. No, this is just that you take something, you add something, and it makes something else. And what happens with data is you start getting data, and then you start monitoring the data, and the monitoring of the data creates more data, and then you monitor that data, and it creates more data, and
well,
each
and
one.
it gives you outputs, which is more data.
Yep, exactly. And
Right.
those things. So there's the core process of the data associated with the core process. There's the metadata on top of that process. There's the metadata on top of that process. And there's the metadata on top of that process. It's infinitely extensible. And each one of those moves up the ladder is called a layer of abstraction.
Abstraction or
Abstraction.
extraction?
No, no
Because
well,
it seems like it's just extracting something from itself each time.
Abstraction means it's a summary of the thing below it,
Yeah. Okay.
right? So extraction with summaries. So extraction and refining is probably how you describe that.
Okay.
Anyhow, um, around 2005, companies started popping up that could build. There was a company that could build 2,500 different reports about HR from the data that existed about there, and then they developed a scheme that had an overlay on that and an overlay on that, layers of abstraction, and that really was the start of people analytics, early 2000s with big reports. Um, as things progressed, you know, it's been an astonishing explosion of data. And so in the 90s, there were not very many circulated job postings. If you had a job, you posted it on a job board, and that was that.
Right. Yeah.
In the early 2000s, people started distributing these things. They called it programmatic, but it was really just automated distribution to various sources. And that created more data, and the HRIS systems created more data. And so all of a sudden, there's this incredible pool of data, and people have been trying to figure out what to do with it. And the early days of this round of AI began 2008, 9, 10 with big data, as you
Right.
suggested. Sorry for getting so lost in that,
No,
but
this is great. This is great. It's really useful to understand the background and the development of the ideas, especially the idea that we shifted from looking at the processes to looking at binary database
yeah. So let me go
functioning.
to the big data was the idea that you'd be able to observe all sorts of things. There was a very influential article in and about that time called "The End of Science" by the guy who was the editor of Wired magazine at the time. And what he said was, now that we've got all this data, you can look at the data and get better answers without a hypothesis than you can get with a hypothesis. And that was the advent of machine learning, which
Okay.
is machine learning is looking at a great big pile of data and finding the patterns inside of that data. So the next step was language, right? And so some smart people had the idea that you can apply machine learning to language or natural language processing, and that was useful for a variety of things. So in the very early 2000 teens, there were sentiment analysis companies, and sentiment analysis companies looked at all of the text that was generated inside of your company, email, reports, whatever, memos, and find the sentiment inside of those things. So they started to be able to think about looking at employee engagement based on sentiment. And that was when natural language processing started to have a kind of an interesting boom, and people started collecting all sorts of data and all sorts of text.
You mean that's when we all started getting surveyed to death?
That's exactly when we started getting surveyed.
Yes, I noticed that.
But that natural language processing, the way that you did it was you got all the words in the little universe that you were looking at, and you figured out the relationship between this word and that word throughout all of the stuff, and that yielded a view of how people were feeling. Sentiment surveys. Fast forward 5 or 6 years, and that idea morphed into what if we had all of the data in the world, and what would that look like? Or a large language model. And the large language models were begun as a response to the Google monopoly. The idea being Google has all of this business and all of this revenue. Why can't I have some of it?
Right.
And so the large language models were evolving to attack the revenue base of Google. That's
Right, because
a
Google was
plum.
out there mapping the world and photographing everything, and they've been on the "we're going to get all the knowledge in the world" train for a while.
Yeah, and so this is they collected all of the data, and this is the information extraction layer that we're talking about now, with large language models like ChatGPT or Claude or Grok or what are they called? The Google one, Gemini. I think it's Gemini. Anyhow, so now you have these large language models, and a large language model is roughly all of the text ever created in one big bundle, and then you look at all the text ever created and you isolate words and phrases inside of that and see what they're related to. And that gives you a very interesting tool that looks a lot like autocomplete. So if you say Mac, it could mean computer, or it could mean truck, or it could mean Big Mac.
Right.
And so
Or the guy down the street.
Or the guy down the street. And so a large language model predicts which one of those relationships happens in the given text context that you're looking at. And that's all they do. The products, ChatGPT, Grok, Claude, Google's product, and soon Apple and everybody else will have a product, puts a layer of software on top of the probability table. So imagine that you take that entire corpus of text, all the text ever written, and you reduce it to a bunch of mathematical relationships. So the words disappear, and it's the probabilities that are really the key to the large language model.
Is that what tokens are?
No.
Okay.
No, that's not what tokens are.
Okay, I'll ask you about those later.
Yeah. So the software that presents as large language models today is a combination of that math and underlying what are the relationships of all things and some sort of interface. And the interface design is pretty interesting because I think something that's not very well recognized about AI right now is that we are in a marketing hype bubble. And the marketing hype is the most interesting marketing I've ever seen.
Yeah.
And here's how it goes. If you don't learn how to use our stuff, you're going to be out of work. That'll be $20 a month, please.
Right. Exactly. No, yeah, but I mean, we've been hearing that since big data.
Well, except now it's louder.
Yes.
It's noisier. It's more compelling. It's more frightening. The newspaper is full of kind of bullshit articles about job loss. It's not actually true, but there's a lot of stuff about job loss. There's a lot of stuff about job displacement. There's a lot of stuff about reskilling. And that all adds up to everybody's anxious about being replaced by AI. Everybody everywhere is anxious about being replaced by AI, which makes you a potential client for a company that sells AI.
Right.
Because,
no, I get that.
Right. And I just think I think it's brilliant marketing. I think it's also not very true.
I agree. Let me stop you here and shift gears just slightly. So, how is AI, when you interact with an LLM, different from interacting with more traditional search? Because to me, it feels like you asked a question to both, but I think it operates completely different, and the results you get are qualitatively different.
Well, so in search, let's talk about search in two phases.
Okay.
In search, in its glory days, you would go to a search engine and look for something, and it would give
What are
you
the names of the planets?
It would give you a list of places that have information about that. And it would try to make that the best list of places that have information about that. That was the glory days. Today, it's just an advertising vehicle, and the answers that you get are not very good. But that model, look for the answer to a question, is how people think you use large language models. And you don't get the same response. Over here, you got a list of different places to look, and you could understand what their biases were. And they all had sort of different views of the answer. One one company might say there are 9 planets, and one company might say there are 10. And both are kind of true. In a large language model, in a chat large language model, you get a prediction of the words that should go together to answer your question. The likelihood that it is right, although I'm not sure this is the best way to use it, but the likelihood that the answer you get is right is in the 70-80% range. And over here in search, it felt like the answer to your query was 100%.
Yeah. I mean, there's a similar refinement process where you get the results you get and you go, oh, that's not what I meant. And you try, sort of make sense of what you got and where the disconnect is and try to refine your query. And I think that happens similarly with the LLMs. But what happens between your query and the output by the LLM? What are the differences in how it works?
Well, let me drag you back to the first question because the difference between the two is profound. So in search, you get a list of references,
Right.
and you can go explore those references. In a
Right.
large language model, you have to ask for references, and they may not be real. If you ask for references, it's very likely that some of them will be made up. Very, very likely that some of them will be made up.
And
And
it's
so
not because they're trying to lie to you. It's because what they're doing is predicting words in an
words.
order.
Yeah. Large language models don't know anything any more than Google knew anything.
Right.
It's just Google is an index, and large language models are more like summarization tools. And so you go ask a question in a large language model, and it won't give you a list of references. It'll give you something that looks like a detailed answer, and there's only 80% chance that it's right. It's a sort of a C minus.
B
And
minus.
huh?
80 is a B minus.
I thought you went to law school.
I do. I used to teach law school. I'm telling you, 80 is a B minus.
Oh man, not most places. Anyhow,
90 is an A, 80s are a B, 70s are a C.
oh man, that's great inflation. That is terrible. An 80 is a C
Oh,
minus.
yeah. Okay.
It gives you the likely set of words that might answer your question. That's what a large language model does. It doesn't give you pointers to other references inherently. It doesn't give you things to choose from so you can make up your own mind. It offers a single opinion about what the right answer should be. If the probability tables are correct, this should be the answer to your question.
Yeah.
Which
And
means
how does search work? I mean, search, you would put in a set of words and it would go look for that set of words and the words that it knew were connected to that set of words, right?
the search model, the search indexing model, is more topic oriented than that, and it is more individual word oriented than that. So in a Google search, until fairly recently, what you did is you typed in the noun or the verb that you were
Right.
looking for.
Right.
And
Planets.
if you go to a large language model and you type in one word, it'll try to figure out what you want, but it'll do better if you give it a whole question. And the longer and better and more specific you can make your question, the more likely you are to get a useful answer, is the whole thing over here. Over in search, if you put the word if you put the phrase peanut butter, it'll give you a list of peanut butters. Best peanut butter will give you best peanut butter. Over here, if you put in best peanut butter, it might give you a list. It probably is not going to give you references, partly because the design over there is to keep you inside of the system rather than over here. The design is to get you outside of the system.
Okay, so I lost track of which over here you were talking about.
Search. So search is over here,
Okay.
and you can't see my hands.
Right.
In search, it's all oriented around individual words. In large language models, it is oriented around the universe of things that wrap around a word. And so it starts with that universe. Over here, the keyword brings up keyword related stuff. Over here, the keyword brings up an answer and a context. And over here, you poke through the results and find what you want. Over here in large language models, you have to ask more questions to get what you want. So that's the difference, I think.
Okay. And how do you assess the responses? I mean,
well that's a really interesting question, because you really don't go asking questions that you know the answer to, right? That's a kind of a silly thing to do. Uh, if you're a teacher and you want to move the class around, you can ask questions that you know the answer to. But generally speaking, as a user of knowledge, if you know the answer, why would you have the question? Right. So everybody who uses a search engine or a large language model is trying to get a better understanding of something. In the search model, you can go look at the various sources and opinions and find out your own opinion. In the large language model, the large language model begins by offering you an opinion. And that's the fundamental difference is over in large language models, you get an opinion. And over in search, you get the answer that you'd get if you looked it up in a card file or a library file of some kind, right? The search
you
is
get resources.
you get resources. Search is more like Dewey Decimal System, and I don't know what large language models are like. I fail to have the metaphor there, but the
Well,
large
I mean,
language model
to
wants a
me, they
deeper
appear to
interaction.
be librarians, but I don't know that they are.
Well, so Google search engines are librarians. That's exactly what they are. They're indexers of resources. In um, a large language model, it's kind of like there's a person at the front door of the library with a magic 8 ball. And instead of going in and browsing the stacks, you stop and you talk to the person and they shake the magic 8 ball, and it gives you a magic 8 ball kind of answer.
Not today. Try again.
Exactly. And so it is a layer of abstraction removed from search. It's the next layer above search because you can ask and refine questions. So for me, the best part of a large language model is the ability to refine the question. It's useful for other things. You know, you can get emails written and you can get documents created. There's all sorts of things that you can do with large language models. I find the best use of them is to refine questions. And, and really good questions are not a keyword in a window. Really good questions are, a great prompt might be 2 typewritten pages long.
Yikes. So, okay.
Also, so let me give you an example of
What
what
does
that.
it take to get there? I mean,
It takes an interaction with the large language model over time. So, let's say this is the kind of project I spend some time on. Let's say you want to understand a market. So you might have an initial prompt that is, what are the 10 most important categories in the pharmaceutical market? And it'll come back and it'll say, blah, 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 10 categories. And you might say after that, are there any more that are important enough to put on this list? And it'll come back with a refined answer that'll give you those things. So now you've got the 10 areas or 15 areas that you want to explore. The next question is, what's the difference between those things? Go through and make me a document that says, here's the boundaries of each one of those things, and here's how they work together. Then you can say, well, what companies are involved with each one of these things? And get an answer. And then you can say, what are the revenues of those companies? And you may or may not get an answer depending on the model that you use. The best ones are up to date enough to give you a pretty good answer to that. And then the next thing that you might ask is, what are the research and development trends in that market? And the thing that might say after that is, where are the vulnerabilities in this market? So we've got all these categories, we've got all these companies, we understand what they're doing. What are the vulnerabilities inside of the market? Because I want to put a product there. And then you can start to shape the product in it. So it's a long, engaged, disciplined look at a complex area that you simply couldn't do with a search engine.
Yeah. And it's amazing that they can pull this information, but we don't, but they're not pulling information from a specific source. They're making a prediction
Yep.
about information, and they can point you to sources that may or may not exist. So when you get this information and it's 70% right or 80% right, what do you do with it to make it useful so that you can rely on it?
Well, so I'm going to give you two different answers to that
Okay.
because more answers are better.
I agree.
The first thing that's really worth knowing that's a pickup on the thread that I was starting is you don't ask questions that you know the answer to. And so if you go to the machine and you expect it to give you a usable answer like you might get out of a search engine, and you don't know whether or not the answer is sound, how do you tell? Right.
This
And
this
so
is what I'm asking.
that's
Don't you
one
have
side
to
of
go
it.
back to a search process so that you can assess the sources or validate or
Well,
verify?
so I think another way of saying this is effective use of large language models requires thinking. Um,
Yes. Some
right.
people do not enjoy that, especially people who are used to getting answers out of computers.
Right. No, this is the hardest part of this transition that we're going through. Is we've built an incredible universe of processes that are really about putting data into forms. That's software all the way
Right.
up
But
through cloud
that's
software.
automation, right? I mean, forms means it can be automated.
Well,
It requires the same information over and over.
except what happened was the filling out of the forms became the work.
Right.
Right, right,
Right.
and
Right.
so lots and lots and lots of white collar workers are trained to put an answer into a cell in a spreadsheet or an answer onto a slide in a PowerPoint or something like that.
Right. And that's how we got all this data.
Um, right, but what large language models do is take you a level above that,
Okay.
and into how does this actually work, and into things beyond, right? Because large language models are not very good at giving precise numeric answers
Right.
because that's not
It's not how they work.
it's not language as we might understand it. I
So
lost my
what do you
train of thought.
do? How do you know? How do you know if the answer that you're getting from an LLM is sound?
For me, for me, um, the more questions that I ask, the more comfortable that I get with the output, and the more you can explore the answers, the more certain you can become of your own point of view, right? Because with large language models, the best use of them is to help you arrive at a discrete point of view about something, right? And so you have a call and response sort of relationship with the machine. rather than a put a quarter in, get a soda out kind of relationship. That's the search engine relationship. It's
Right.
more,
They give you things that look like answers that aren't exactly answers because you have to keep examining them.
well, it's kind of like this conversation, isn't it?
Yes. Yeah, well, I think learning is iterative, and I'm not objecting to that. My concern is that I mean, these things look real. They look credible. They look plausible. And yet, attorneys are filing briefs in court citing cases that do not exist for legal rulings that have never been made. Um, and I just, it's like, okay, I can get an LLM to write a brief for me, but then I have to go and look at every single case that it cites to make sure it exists, and that's not hard. There are actually programs based on search and matching that will that will pull all the sites out and go and check your citations. But then you have to read the cases and make sure that and if they're not the cases that you're familiar with and that you have found, I mean, sometimes it can lead you to a new case that you didn't know was out there, but a lot of times it just you know leads you into a dark, scary alley where you're just going to get in trouble.
well, this is what you're talking about is the work that somebody has to do in order to deliver a briefing, right?
Yeah, yeah.
That
But I
no,
would do that work and I would create the brief, and then I wouldn't have to go check it at the same level. So for me, getting an LLM involved um, may cause more time and effort, and I bill by the hour, so that makes it more expensive for the client. And so I don't, I'm not sure that value is there yet for me.
well, so I think you are a sole practitioner. And so the way your workflow works, as I understand it, is you get a question and then you start looking for relevant information about that question and start forming your opinion about how that question could or should be answered. You find cases that you can cite to support your evolving point of view. You write that and you ship it. Right. So the process of research and creation is simultaneous in your approach.
Yes.
If you worked in a bigger firm, depending on the importance of the output, somebody would look over your shoulder and edit it and check it. In big firms, it doesn't. It may be created the way that you're talking about, but it doesn't get distributed the way that you're talking about. There is an approval process for things to go out from a big firm, at least some of the time.
Right.
Isn't this what partners do with young attorneys?
No. But I don't want to go down because that's not useful to the people listening. But let's just assume you're right. That
Well, of course.
know.
Of course I'm right. What do you mean?
So what you're saying is, in a world of LLMs, you need a paralegal, Heather. If you
Or
don't want to do the work of checking the work of the LLM, um, you can hire someone to go do that. And the thing is I still need to understand the underlying material and reasoning and validity of that material because I have to go talk to a judge about it. I can't. It's not just ship it. It's like I have to understand this and be able to apply it in a dynamic situation that's evolving as I learn more information about what happened.
so I don't know how to move it off of your sole proprietor experience, but I will give you an example from my morning today.
Okay.
So I needed to write a short blurb about something. and I needed to do it for a client. And so I sent the draft. And then the client and I got on the phone and looked at the draft together and reviewed it and modified it, and came to some agreements about what it should actually be in placement of words and that sort of thing in it. And then it was ready to go. But it took two people covering similar territory. She got a step up on it because I gave a draft product, but the draft product wasn't the final answer. The final answer was the result of feedback about the draft product.
Right, but I'm not asking about how you ship it. I'm asking about how you assess the validity of the draft. I mean, when somebody else is creating it, when an LLM is creating it or a paralegal is creating it, how do I know that this is valid? Well, I trust the paralegal because I know what they're doing and that they will check. But how do I trust the LLM?
By using it the same way you trust a paralegal. You do not trust a paralegal on day one. You trust a paralegal. Trust builds gradually over time with evidence.
Okay, so are you saying that LLMs are going to become more accurate?
No,
Okay.
no. I'm saying that you will get more familiar with their strengths and weaknesses and be able to assess partly based on your understanding of their strengths and weaknesses, just like
Okay.
you do with a paralegal.
Okay. Okay. So can we agree that when you create something in an LLM, you have to check it?
Yes, we can
Yes,
agree on that. Yes,
we can
absolutely.
agree on that. Okay. Um, and when you find something with search, the checking it is baked in because you don't get an answer, you get a list of sources that you can assess their
Exactly.
credibility.
Exactly. That's right.
Okay.
That's right.
Okay.
That's true. That's actually a very productive conclusion to this little snippet of the conversation.
Okay. So how do we help people understand one that they need to check and two how to check? Because they're not trained to do that.
These
Either
are when they talk about reskilling, this is what they're talking about.
okay.
This is what they're
Okay,
talking about.
but
And we don't really know yet
okay.
how to do this. And so the way that you figure out how to do something like this is you do a lot of it and you get a lot of it wrong and you look at what you did and you go, oh, I got that wrong, and you use the feedback to perfect the process. This is what everybody's used to Google, but the process of getting to Google in its heyday took 15 years of search engine development, and an entire wave of search engines that
Right,
looked like they were as good as it could get till Google
right,
came along
right.
and surpassed them. But it didn't happen overnight. We didn't learn how to use them overnight, and we learned how to use them over time. And the same thing will happen here. So how do you train people? The first thing that you do is you give them problems to solve, and you set them on the LLM as a way of solving the problem, and then you review the output and build confidence that way, because the next wave of jobs is going to be this uh, monitoring the output of machines. I'm reminded of a Kurt Vonnegut short story about elevator operators. Um,
Right,
so in the beginnings of elevators, they put people in them because elevators took away jobs. And they put people in the elevators to push the buttons in the elevator, right?
right.
Um,
And announce the floor.
and announce the floor, because there was a transition and there were people who needed to do things after the transition. We'll see some of that same sort of stuff here, because the work is just like the elevator operator's chair. It's monitoring the output of the machine in order to do something productive with that output.
Right, but don't we have to help people learn to ask really good questions?
I don't know who we is, and I don't know.
To date, when we get information out of a computer, we think it's real. We think it's an answer. Or we get a resource and we can figure out whether it's valid or not.
Mm-hmm.
But that's not what our human experience of interacting with LLMs is. LLMs are very certain and they're very assertive, and they know what they know, but what you're getting is simply a prediction based on the patterns of language and to some extent the quality or the quantity that what it's looking at appears. And so I think it's how do we know that we're even getting a 70% quality answer? And isn't this really easy to manipulate by the data that you trained the LLM with?
I'm going to give you an answer to part of that question, then we'll come back to the real question here. So when you described the LLM, when you, in that last question, described the LLM, you imbued it with human characteristics. You said, they know, they assert, it's certain, all of those things.
Right.
Those are your projections. This is a machine. It is not a person. And
right.
The first thing that you have to do is stop treating it like a person. Right? Stop calling it a person. Tell it to stop calling itself a person. If you go into my LinkedIn postings over the last several months, you can find a prompt that tells the LLM to stop it. Like, just stop it. You're not a person. Don't act like a person. Do not try to have a relationship with me. Answer the goddamn question.
Right, but they're designed to do that, and we're designed to see them that way. We anthropomorphize everything. We name our cars. We name our, plants.
You of all people know that there are lots of things that we do that we shouldn't do.
But you have to take the users as they are and take the LLMs as they are and understand the interaction to understand where you can see the potential problems and risks.
So now you remember that in the maybe between 2015 and 2020, I built and ran and designed ethics boards for AI ethics boards. This is why.
Yes.
This is exactly why.
And it's needed now more than ever.
Well, and so the problem is that the people who design these things have this marketing agenda that doesn't want to train people. If you're going to use this stuff, this is like
they're selling efficiency.
They're selling dependency.
Ooh.
Damn. Well. So I've tried a lot of different ways to use these things, and what I find is that if I don't spend real time thinking about the topic, the answers that I get turn out to be flawed in ways that you can't see instantaneously.
Right, because you have to actually understand something about what you're asking to be able to assess the accuracy of the response.
Yes. And so one great example here is for a client, I built a table. And the table was about client acquisition costs. And it had 10 columns of information. He got it, read it, and said, your spreadsheet doesn't make any sense. And it never occurred to me that he would read the table as a spreadsheet, because I built the table as a series of incremental questions being answered, and he wanted the math formula inside of the table.
Right, right.
And
Because it was a table.
Because it was a table. And I was flummoxed.
It's a chart. It's just a chart.
You remind me of a little boy and goats.
And a goat. It's a ducking chart.
No, it's just a chart. Anyhow, that kind of error, that kind of complicated error where it looks like the problem is solved till you get it pressure tested by some other human being, is...
Often you need an expert as that other human being.
Well, I think that's extreme.
Right.
You need somebody who knows what they want, as the other partner, and you need to be able to understand and communicate what they want. So using an LLM is always going to be in service of something larger. You wouldn't use one just to use one.
Well, like you would.
No, I think my usage is a lot like having a ball machine on a tennis court. It's a partner to practice with. An always-on partner to practice with. That's great. That's great stuff. But you have to be cautious with the answers. And it is easy to produce voluminous answers with these things.
God, they're so verbose.
And that's where the puzzle gets. Puzzle is. And so you and I had a conversation recently about layers of abstraction on top of human experience.
Yes.
Right. And so you have the world that's out there, and you perceive it with your senses, and the senses don't collect all of the information. So you have the first layer of abstraction is your perception of reality. The second layer of abstraction is the language that you use to try to tell somebody else about your perception of reality. And the third layer might be math, where you quantify as a part of explaining to somebody else your perception of the world. And you build on those layers of abstraction. We're going to learn how to do the same thing here. We're going to learn how to do exactly the same thing here, because what a large language model is, it's not reality. It's not language about reality. It's the probabilities about language about reality. Right. So there's always going to be missing detail, because that's what happens with levels of abstraction, is you miss detail.
Exactly.
And
the more you summarize, the less you can include.
Yes, exactly.
And so you get to the big ideas, or the most important ideas or facts, but you don't get everything. And sometimes you need more.
Yes.
Than what you get.
That's exactly
to make sense of it. And then at least I do, when I am trying to understand something, I bring my experience and my filters and my ways of looking at the world. And so one of the ways I look at the world is I'm always looking for whether it's true or not, because that's part of what I do as a lawyer. Now I do not believe in objective truth because I'm very familiar with humans. And so one of the things that I do with my law students when we're talking about evidence is I would send them all out into the parking lot to photograph a specific car and then send me the image. And none of those images were the same. No two people see the exact same instructions and the exact same car in the same way. Even doing something as non-loaded as taking a picture of it, just for the sake of taking a picture. We all see things differently. We all bring our own perception and our own perspective, literally, to whatever it is we encounter. And so there's that interaction that's really important too, is understanding who's receiving the information and what they're likely to do with it.
Yeah, that's all on you right now with LLMs.
Yeah, I know. I know, but we don't realize that.
It's as
Because
if so one of the interesting things is if you ask the same question over and over again of an LLM, it generally will give you a different answer every time because they're supposed to provide novelty.
right, right.
And
And
so
yet
it's
our scientific method, when we're trying to learn the truth, is to come up with a hypothesis, do experiments, until we can repeat the results of those experiments, and the results seem to answer the hypothesis or validate or invalidate the hypothesis. And that's not what LLMs do. So we need to be able to understand the value of this information in different ways that are not necessarily based on our normal concepts of truth or accuracy. And I'm just not sure how to wrap my brain around that yet.
well, it's
Because
early.
I think there's value there, but I don't understand it and I can't contextualize it in the way that I view reality.
So
And I ask the question.
let me give you a longish answer to that, and then we should bring this conversation to a close and pick it up. Right,
Okay.
this is really good, but we need to bring this to a close. First thing is, imagine that everybody is now in the business of standing in front of an audience and asking them what they see. Your particular experience with that particular example is probably very useful. Because what I need to do as a user of a large language model is understand that it's going to give me a variety of perspectives on the same thing, and that the answer is some synthesis of those varieties of perspectives. So,
Or the ability to assess multiple perspectives and say, oh, I think that one's makes the most sense in this situation.
right.
And that's, that's part of the value of diversity. That's part of why you want lots of different voices and perspectives and backgrounds and experiences in the room when you're trying to figure out what the right approach to
That's right.
doing the next thing
We
is.
should dig deeper to that because I'm going to leave you with the conclusion here, which is AI is a new form of literacy. Large language models are a new form of literacy, and if you imagine the transition from an oral culture to a written word culture, which basically took from the invention of the printing press till the invention of the newspaper, or 300 or 400 years,
Yeah.
as we learned how to use language differently for different things. And we learned by experience. We learned that some things work some ways and some things don't work some ways. But we learned from experience and we built our models of what literacy is, not from a theory, but from experience. And we're in a phase where we are learning what this new kind of literacy means. And a whole lot of the things that we know about how to navigate the world will require some adjustment because we have a new factor. And the new factor gives us a really good additional information, but we don't quite know how to handle it yet. As we get better and better, imagine this conversation 10 years from now, there'd be a whole bunch of things that we know and know how to do that we didn't know how to do today. Just like we didn't know how to use a search engine in 1998. we got pretty good at it over the next 25 years. So let's pick this up. It's a great conversation. I really, really, really appreciate your intensity and your unwillingness to take a bullshit answer.
Well,
You know,
you're familiar with it.
I am. So let's draw it to a close. Again, this is Heather Bussing, who is one of the partners at HR Examiner, and I'm John Sumser. And thanks for listening.